1.2, use segments and congruence. Some new vocab for us here. Some of these we're going to hear a lot in geometry, some not quite so much, but it definitely is important that we go through them. The first one is a double word, either postulate or axiom. They are synonyms, and it's a rule that's accepted without proof. So what you're going to see in our geometry book is you're going to see like postulate 1 in this section, postulate 2 comes up, postulate 3. And in our textbook, they simply number them by what order they show up in our book. So I don't ever want you to memorize a postulate by its number because that's different between textbook to textbook. So there's no official like postulate 21 in geometry. Our book just numbers them for order. Our book does call them a postulate, but they do want you to know that some textbooks call them an axiom. So just keep that kind of that name in the back of your mind that if you hear somebody says, well, I have this axiom in geometry, it's the same thing as a postulate. And the theorems are rules that can be proven. So both postulates and theorems are words that we're going to see a lot of, and they're going to give us information that we can use to solve different problems in geometry. Our next vocab word is coordinate, the real number that corresponds to a point. We're used to a coordinate on a grid, on a coordinate plane, but you can have a coordinate on a ruler because the number that corresponds to a point. You can have a coordinate in the sky when you have like longitude and latitude things. Those make coordinates with your GPS. Airplanes go to certain coordinates as well, differing on how high or how low or where they're at. Okay, so coordinates just mean they go to some kind of point. Distance, the absolute value of the difference of the coordinates of 2 points. Okay, notice this word, the absolute value. If you remember the meaning of the word absolute value, it means the distance from one place to another. And because of that, this is always positive. And if you think about it, it makes sense that distance will always be positive. You don't go -7 miles to get somewhere. You go 7 miles. And it doesn't matter if you go east, west, north, south. It's still 7 miles. So when we find the distance, the absolute value of the difference, the subtraction of the coordinates of 2 points. And we'll do some distance today in 1.2, and in 1.3 we learn another more complicated distance. Between, I always think it's funny that this book even has the word between here, but when 3 points are collinear, 1 point is between the other two. Notice it's kind of hard to define without using its own word in the definition. And remember, if I've moved too fast for you through these, just pause your video and copy down what you need to. And remember, I don't need things memorized word for word. I simply need you to understand the concept behind these. Okay, probably our most important word that we're seeing in our vocab today is congruent, and congruent segments here. Segments of the same length. So one thing I want you to know is when we talk about congruent, we have this symbol, and this symbol is an equal sign with a squiggle above it. Okay, that is the congruent symbol. And this congruent symbol we're going to use when we talk about objects, okay? And I give you this note right here that numbers are equal. So we've had a lot of solving for x. X equals 3, x equals 7, x equals 22. Those are because we have numbers involved, things are equal. But when we start talking about objects that are the same size, the same shape, they are congruent. Objects cannot be equal to each other, but they can be congruent to each other. So objects are congruent, numbers are equal. All right, let's keep moving on these notes and let's get our first postulate behind us. So our first postulate here says, the ruler postulate, the points on a line can be matched 1 to 1 with real numbers, and the real number that corresponds to that point is the coordinate. See if I can fit it in this space. Coordinate of that point. And the distance between 2 points A and B, written as AB, is the absolute value of the difference of the coordinates of A and B. Okay, so what this is kind of saying is if you take point 1 and subtract it from point 2, or subtract point 2 from it, I should say, and take its absolute value, you'll find how far between the 2 points they are. And to be honest, you've been doing this ruler postulate all your life. Let's flip the page, and right at the top we're going to practice this, and then we'll kind of talk about why they have this postulate the way they do, okay? Okay, so they want us to measure the length of this segment CD to the nearest 1/10 of a centimeter, okay? And most of you, if I give you your handy-dandy geometer that we just got in class, you would line the 0 up at the C and you would try to see how long it goes to the D. That's the natural thought that we do. And because we usually use 0 as our first number, we just look at the second number and say this is how long it is. But if you notice right here that C is lined up at 1 and D over here is lined up a little farther back, right? So if one is at 1 and the other one, I don't know, what would you say? About 4.7, 4.8-ish? Kind of hard to tell, right? To find the actual length, we would have to subtract the two. So we could do 1 minus 4.8. Well, if we subtract that, we'd get the absolute value of negative 3.8, or just take what's the absolute value of negative 3.8? About 3.8 centimeters. Okay, so this is where the ruler postulate comes in, where it says, well, take the markings underneath one number of coordinate and the markings at the other coordinate and subtract the two numbers, and that will tell you the length between them. Good idea. If you're starting at 0, you probably haven't done a lot of subtracting, but of course if you subtract 0, you get the same number you got at the other side, so maybe you really did it, but just in your head. All right, before we go on to postulate 2, I want to pull some things into the margin. I think I warned you on your last notes that if there's something in the margin, this is important. You really want to make sure that you write it down, and you want to make sure you understand the concept, because the reason I pointed it out and put it in your margin is it's going to affect a lot of things on our quizzes, tests, and just our knowledge in general, okay? So, I have to remember I'm on this. And of course, it looks like my symbols are not going to show up, so let me go ahead and redraw what I had drawn there. Right here, I had CD, and I had the segment mark above it that we learned about on 1.1. CD means the line segment with the endpoints C and D, okay? Now, let me pull my next box off, if it will let me. It's being very picky. I don't really care how it comes, as long as it comes. Okay, the next one I want to do is just CD, no line, okay? Just CD. And this means the length between C and D, okay? So when you see CD with a segment above it, that means look at the actual segment. And that segment could be congruent to something because it is an actual object. But if it says CD with no line above it, it means I want you to measure it. I want you to find the length of it. And that means this CD is going to equal some kind of number. Like over here, it equaled 3.8. So I would write this one over here, CD equals 3.8. Okay, so if I want to know the length of something and I want a value attached to it, I would use an equal sign. But if I want something that's just, I'm talking about a segment, and I'll say like CD is the same length as segment FG, well then those two things would be congruent if there's just the segments. But if I throw in their length, like 3.8, I'm going to make them equal. Okay, so it's super important that you realize the difference in the notation, that without the line, I want a number, but with the line, it's going to be congruent to something. All right, our second postulate, okay, is postulate 2 here, and it talks about segment addition postulate. So if we're reading through this box right here, we're in this box right here, it says if B, which you see right here, is between A and C, then AB plus BC equals AC. And if AB plus BC equals AC, then B is between A and C. Seems pretty simple, right? You can follow that and figure it out here in geometry. I'm going to be honest, they use all kinds of symbols, they use all kinds of things, and sometimes kids look at me and go, wait, that didn't make sense at all to me, okay? And I agree with you, it can be confusing. So in the margin, I've put it in a much simpler terms that I'm going to use over and over and over to remind you. This is what that postulate's saying. Part plus part equals whole. It's saying, when I look over here, that this part here plus this part here equals the whole thing. That's all that postulate's saying. And using that setup, we're going to be able to solve for a lot of missing holes or a lot of missing parts, because we know that on one line segment, part of that segment plus another part of the segment will equal the whole segment. All right, so let's move to the bottom of the page and see what we can do to practice this. Now, I'm going to tell you right now, our first example is super simple. Most of you wouldn't do it this way, but I want you to kind of see the concept of what we're using with this part plus part equals whole. So on the road trip, we're going on a road trip here on a nice straight road, okay? And so straight, we can call it a line segment. And it shows our locations over here. So our starting point here and our destination here at D. And somewhere in the middle, we're going to need to stop at a rest area R. Okay? So we're going to find the distance from the starting point to the destination. So just so you know, we're going to do a little part plus part equals whole. Okay? So the first part is we leave our starting point and we go to our rest area. So we're going to call that S to R. And then when we leave our rest area, we're going to go to our destination and we'll call that segment R to D. So we have a part plus part equals our whole. Now, quick notice, you'll see in what we wrote there that nothing has a bar above it. And because it doesn't have a bar above it, that means I can replace it with a number. So I look up at SR, how long from S to R? Well, it looks like it's 64. How far from R to D? Well, it looks like it's 87. So I can replace it with that and find out that my whole from S to D, do a little math there if you can handle 64 plus 87, and it looks like I get about 151. So our distance from the starting point to the destination is 151 miles. I'm going to be honest, I could have given you that problem any old day, and probably most of you would have had it solved in a lot less time than it took me to just explain it. But what I want you to see is the part plus part equals whole. Again, something your brain already knows how to do, but we're going to use it in other ways as well. So let's turn the page and let's see what we have on the next page. All right, this one is slightly different. When you look at the top one here, it says use the diagram to find KL. Okay, I just want to kind of point out here, do you notice this KL here doesn't have a line above it? That means it wants me to find the length. It wants me to find the number that goes to KL. So I look at the picture and I definitely have some parts and some whole. So I'm thinking whole equals part plus part. Well, the whole thing goes from J all the way to L, so I'm going to call the whole thing JL. One part of it that I already know is J to K, and then I'm looking for KL here, which is the second part of it. Okay, so there's my part plus part equals whole, and now, again, there's no lines above those. I can replace those with numbers. So what does JL, what is the value for JL? I look up there and it's 38. And JK, I look up there and it has a length of 15. But I don't know KL, that's the missing piece. So when I look at my math equation, I say, how can I get KL by itself? Well, it looks like 15 is being added to it, so I could subtract 15, the opposite, and 38 minus 15 is going to be 23. So KL has a length of 23. It asked me for the length. I know that because there was no line above it. They asked me for a number, and I was able to find that using some subtraction. Okay, so I do want to do the one in, let's keep going and I'll do the margin ones last, I think. I'm trying to think how I want to do these, but I think that's how I want to do it. Okay, on example 4, it says plot these points in a coordinate plane. So let's go ahead and plot them, and I will tell you, anytime you plot a point in a coordinate plane, please, please, please label it, because sometimes we don't know what we're doing with it yet or what gets connected to each other. So just when you plot them, please label it. So I'm going to go to 4, 5 first. I put my dot there, and I'm going to label it F. I go to -1, 5. I put my dot there, and I label it G. 3, 3, and I label it H. And 3, -2, and I label it J. Okay, so I've plotted my 4 points just like they asked me to. I labeled them so I can figure out what I'm going to do from there. Okay. So they want me to determine whether FG, so F to G, segment FG, that's telling me join those 2 points. So here's segment FG, and segment HJ are congruent. They want to know, are they congruent? Well, what does it mean to be congruent? It means they have the same length. Okay, now, 2 different ways you can do this. I'm going to show it to you both ways. And you get to choose when it's time for homework, or if this comes up, you can do what you want. So F to G was my first setup there, okay? Notice it was 4, 5, and -1, 5. If you notice, my 5s were the same, which puts them both up here at the same thing, which means they're just across from each other. So those are the same. So what I'm going to do is use that rule from the ruler postulate that says take your numbers, 4 and -1, and subtract them. Well, I do 4 minus -1, I'm going to take the absolute value, so I get minus and negative becomes plus the absolute value of 5, which equals 5. That one has a length of 5. Let's check H to J. When I look at HJ and notice it's a nice vertical line, I see this matching 3 in the x values. I'm going to ignore that, and I'm going to subtract the other two numbers, 3 minus negative 2. Once again, I get a minus negative, which becomes a plus, and I get the absolute value of 5, which is 5. Okay, do they have the same length? They do. They both have a 5, so they have equal length. So notice here, these have the bars on them. If the bars are on them, you cannot put an equal sign. But if the bars are on them, this segment is congruent to this segment. They have the same length. Okay? Now, I told you I was going to have another way to do this, and I need to just stress this one here when you can do this. Because I have a horizontal segment, it goes across, or a vertical segment, okay? Exactly horizontal or exactly vertical, you are allowed to count the spaces between those to find the length, okay? So I look over here, I'm counting the spaces. 1, 2, 3, 4, 5. Yes, exactly the same number I came up with here. Over here, count the spaces. 1, 2, 3, 4, 5. Same number I came up with here. Okay? If you don't want to mess with the coordinates and you just want to count them, that's fine. One thing is you do need to have them graphed to be able to count them, but it is a quick way if the lines are horizontal and vertical. And we will talk in 1.3 what happens if they're not horizontal or vertical. Okay, so let's go towards the bottom here. Keep going, and remember, we're coming back for those margin ones. Okay, it says, for number 1, find the length of segment AB to the nearest 1/8 inch. I would need my handy-dandy geometer, and I'm going to be honest right now, I don't have it with me. That's not a good idea on my part. Should have stuck it in my notebook. But because I don't have it with me, I'm not going to get you the answer here. But I'm hoping most of you, when you lay it down there, use the inch ruler. If you look at your geometer, one side has a centimeter ruler, one has an inch. Use the inch ruler, and then go to the nearest 1/8 of an inch, okay? I would suggest you start and you line A up at 0. And then you just read where B is. But if you don't line it up at 0, make sure you use the ruler postulate and you subtract the two numbers that the A and the B are between, and it will give you the length. Okay, let's look at number 2. A lot going on in this picture. One time it says me to find the length from Q to S, and one time from P to Q. So Q to S is this one, and P to Q is this little one. Okay, so Q to S. Oh, it looks like QS is kind of a hole. So if I think about this, QS is a hole, and that should equal a part plus part. So my two parts here are 31 and 30. Now, quick note, because I didn't state this earlier. I'm not going to be picky and make you write out QR plus RS. I know you can see that. When it comes time to do that, and we will do that, especially when we get into chapter 2 some, we'll do it then. But for right now, it's fine if you just add 31 plus 30 and you say the answer is 61, okay? You don't have to write their whole name out right now. We'll do that when we get into more proofs and such like that, okay? Not to scare you off yet. All right, when I look at PQ over here, it looks like PQ is a part. So if I think part plus part equals whole, and PQ is one part that's missing, the other part looks like it's 31, and I'm looking between these two, and my whole is 56 there. It looks like I could subtract, and it looks like X is going to be about 25. So I think that PQ, did I read that wrong? Is it 55? See, I can't even read my writing here. 55, which will make this 24. There we go. So it looks like PQ is going to equal 24. Okay. That's the danger doing these notes without you guys to catch my mistakes. Sometimes I just do them wrong. Okay. Last example here on 3 before we go to our margin. It says, consider these points A, B, and CD, and are the A, B, and CD congruent segments? Okay. I don't have them graphed. If you don't have a graph paper right now, we have to think, can we do this in a different way? Well, remember my trick from above that says if your y coordinates here are the same, ignore them, and we can subtract our x coordinates. So we can go -2 minus 4. And we always do the absolute value because distance is always absolute value. Well, -2 minus 4 is -6, so the absolute value would be a length of 6. Okay. How about CD? Well, CD, oh, it looks like there I have a 3 on the x and a 3 on the x, so I can get rid of those 3's, and I'll subtract the y coordinates, 0 minus 5. 0 minus 5 is -5, the absolute value is 5. Okay, are my segments congruent? And they're not. So look how we write this. AB, and now I'm going to put the segment above it because I'm talking about the segment, and CD, segment. And we would say they're congruent if they're the same length, but if not, we slash that through there. They're not congruent. Okay, so that's the symbol I can use to say they're not congruent. Okay. Margin. I've got some in there. Sometimes, again, why do I give you these in the margin? So that you can see that they can be a little bit trickier, and that what would you see maybe in your homework that you need a little help with, okay? I think you guys can already see them, so I'm just going to move mine. Okay, we're finding the indicated length. On our first one, it says, what is VW? Notice VW, no line above it, so that means I need that VW to equal a number, okay? So I need this to equal a number. I'm done when it equals a number. All right, so I look at my picture. I have a lot of x's involved, okay? I can't even put x up there. I can't say VW equals x. I need an actual number. Okay, how about a little part plus part equals whole? It looks like one part is over here, TV, that's 3x. The other part is what I'm looking for, VW, which is x plus 8. Okay, that's the second part. So there's the first part and the second part, and they equal the whole thing, which is 32. We have us a handy dandy algebraic equation. Let's go ahead and solve for x. On the left side, I really don't need those parentheses. I put them there so you could see one was one part, one was the other, but we can drop them. Let's join our like terms, 3x plus x, and that will make 4x plus 8 equals 32. Trying to get x all by itself. Next thing to move would be the 8. To get rid of it on the other side, I'm going to subtract. I get 4x equals 24. I still have a 4 connected to x. It's connected by multiplication. So to undo that, I'm going to divide by 4. And x is going to equal 6. So we're all done? We did our problem? No. Nowhere in that directions did it say solve for x. It said find VW. In fact, the length of VW. So what do I do with that 6? Plug it back in. I come up here and I say 6 plus 8. Well, what is 6 plus 8? It is 14. So it looks like VW has a length of 14. All right, let's try this again. And when I look at the next one, it looks like I have a little bit even worse numbers to use here because I have no numbers by themselves or constants. I just have a bunch of variable expressions. So let's try another one here. Once again, though, this time I want to find the length of ST, and it looks like, again, I have a part plus part equals whole. The part on the left is 7x minus 8. The part on the right, ST, is 3x plus 5. And my whole thing is 8x plus 9. Lots of variables, lots of numbers involved. Okay? Now, remember when we do this, that equal sign kind of serves as like a wall. The only way you can cross over the wall is if you do opposite operations. But if you're on the same side of the wall, just join your like terms. So, again, my parentheses don't have a meaning right now. I just used them to hold there so you knew they were apart. So I'm going to join my x values, 7x and 3x, make 10x. Negative 8 and positive 5 make negative 3. And that takes care of my left side down to simplest terms. I still have an 8x plus 9 on the right. All right, it's our job to get the x's together and the other things to the other side, the constants to the other side. So if I want to maybe bring this 8x to the left, I'm going to have to subtract it. It has that invisible plus in front of it. To undo that, we have to do the negative. 10x minus 8x is 2x. Bring down the negative 3 we haven't used. This one canceled, and bring down the 9. Now I'm going to add 3. 2x equals 12 when I added 3 to both sides. And finally, I divide by 2, and x equals 6. Okay, disclaimer here. X will not always equal 6. please make sure you solve, and x might equal a different number, but my examples here, both times, x equals 6. So I'm done? No, my question didn't ask me what does x equal. My question asked me for the length from s to t. And when I look up there for st, I see that it is 3x plus 5. So to find that, I'm going to plug in my 6 and then find that. So 3 times 6 is 18, plus 5 makes 23. So it looks like st has a length of 23. This length right here is 23. We could plug it back in again. If I plug 6 in over here, 7 times 6 is 42. 42 minus 8 is 34. And then I can plug it in again. 8 times 6 is 48, plus 9 is 57. And when I add 34 plus 23, do I get 57? I do, which means everything checks out well. Okay, so don't be afraid to plug it in everywhere to check it out. Okay, so there's our notes. Okay, you have a homework worksheet. I'm going to actually pull up your homework worksheet real quick, or at least part of it, okay, because I do want you to peek at it. So this is the back of your homework worksheet 1.2, and I especially want to point out, by the way, some of these problems are missing on your homework sheet because I didn't want you to do them all. But I do want to point out this back part, okay? Let me get a color going here. It is so super important when you do this section right up here that you read the directions. Some people are tempted to get out their geometer and start measuring. That's not what the directions say. So let's read them. It says, in the diagram, points A, B, C, D are collinear, meaning they are all on the same line. We can see that. Points C, X, Y, and Z are collinear. C, X, Y, and Z, yes, they're all on the same line. Here's where we're going from here. AB equals BC equals CX equals YZ. Notice they're missing the bars, and they all say they're equal. That means the length of AB is equal to the length of BC, which is equal to the length of CX, which is equal to the length of YZ. So this AB and BC and CX and YZ all are the exact same length. Okay, so far that gives us some hint. Then they start giving us some values. A to D is 54. So what I'm going to do is mark my picture up. That's going to be super helpful. A to D is 54. X to Y is 22. So just between here and here is 22. X to Z from here to here is 33. Find all the values. So a hint, okay, I would be looking down here first, because this whole thing is 33, but this part up here is 22. I should be able right now, right, to figure out what is this little length right here then. And by the way, once I know that one, it's the same answer for this one, it's the same answer for this one, and it's the same answer for this one. Fill out all your diagram first, and then go answer the questions on the left, and you'll be surprised how easy they are because you'll have all the hard work already done. Okay? So good luck on the worksheet. Please email me if you have questions. Bring your questions to class. That's the best way to do it, because the more we ask questions, the more we all learn, because sometimes I wasn't as clear as I thought I was when I taught it. So please ask questions if you're not sure. Thank you.